Hey guys, happy Thursday. Today we're going to go over how to calculate pH and pOH. I cannot stress this enough. You need a calculator, and your phone calculator is not going to be good for most of the calculations. You're going to want an online calculator, which the links below link to some good online calculators. So please don't try to do these on your phone. It's not going to go well. You also need your periodic table out, most likely. Nah, you don't need that. Just paper and a calculator. So, reviewing from Tuesday, like I said, at least I believe I said, we're going to talk about areneous acids and bases most of the time. So, in water or in an aqueous solution, acids and bases dissociate, which means they separate into ions. Dissociate, they separate into ions. And so strong acids completely dissociate when in water. HCl is a strong acid, and when it's in water, it will split into hydrogen and chlorine, and all HCl's will split apart. It will completely dissociate. There will be no HCl together when in water. And then it's important to note every acid is aqueous. They're always in water. So this is what happens. You get H's and Cl's. Weak acids will only partially dissociate, which means not all of them split apart into ions. So strong acid will completely dissociate. H is here, Cl is here. Look, none of them together. Versus something like HF, which is a weak acid, only some of them dissociate. So you've got an HF here, but then we've got some H's and F's. So just because it's an acid doesn't mean they all completely separate. Sometimes if they're weak, some of them, and just depending how weak they are, will stay together. And again, just hounding on that, weak acids don't completely dissociate or don't completely separate, while strong acids do. Bases act just like acids. Strong bases fully dissociate. Weak bases only partially dissociate. The only difference is, and we're going off the Arrhenius definition, bases dissociate into an hydroxide ion, not an H+. So here we've got sodium hydroxide, a base. When it's not in water, they're together. When it is put in water, when it's aqueous, they dissociate, they separate. And all of them are dissociated, so this is a strong base. So that is important when it comes to understanding the pH scale and where these numbers come from. So our pH scale, just reviewing, acids produce, and we're going off of the Arrhenius definition, a hydrogen ion in solution. Bases produce a hydroxide ion in a solution. The strength of acids and bases are measured using the pH scale. pH stands for power of hydrogen. Every change on the pH scale is to the power of 10. And so here's our pH scale. It goes from 0 to 14. And every time you go up 1, that's like times 10. So orange juice has a pH of 3. It has 10 times as much free hydrogen ions, or 10 times as much just hydrogen ions, as tomato juice that has a pH of 4. Lemon juice has a pH of 2, and compared to coffee that has a pH of 5, it has 1,000 times more hydrogen ions. So the lower a solution's pH value is, the more hydrogen ions they have. pH of 0 has the most hydrogen ions. It would have 10 times as many as something with a pH of 1, which is still a lot. And so we've got 3 types of solutions: acidic, neutral, basic. You do need to know this table. I would copy this table down. So acidic solutions are acids. Their pH is below 7, and they have more hydrogen ions than hydroxide ions. Some examples. And so here's a picture down here. Acids have lots of H plus, and they've got just a little bit of OH ions in solution. Neutral solutions have a pH exactly 7. If it's 7.01, that's a base. Only 7.00000 is neutral. And at neutral, the amount of hydrogen and hydroxide ions are equal. And water is exactly neutral. And then basic solutions. Basic solutions have a pH above 7, and they have more hydroxide than hydrogen ions. And so down here is a picture of a base, lots of OH, just a little H. In a solution, if hydrogen ion levels increase, OH levels decrease, and vice versa. Think about them like a seesaw. So if H goes down, that means OH is going up, because in a solution, that means it's dissolved in water. There's water, and so the H and OH levels will change. And for any solution, if you multiply the concentration of hydrogen ions by the concentration of OH ions, it always equals this number. That's why we say it's like a seesaw, because they always multiply to equal that number. If one goes up, the other goes down. And that number, 1 times 10 to the negative 14, is known as the ion constant of water, or kW. It's a constant. And here's just a little table so you can see. Now, whenever you're going to use scientific notation, remember scientific notation, a negative number is really small. And so looking at this table, pH of 0, the hydrogen concentration is 1 times 10 to the 0, and then the OH is 1 times 10 to the negative 14. That's really small. That is 0.000013 zeros. So very, very small. And 1 times 10 to the 0 would be 1. So much bigger than 0.000000. And that's at a pH of 0. So very acidic. A pH of 1, the hydrogen ion concentration is 1 times 10 to the negative 1, while OH is 1 times 10 to the negative 13. So still a very small amount of hydroxide, not as small as OH. And as you go up the pH scale, let's go to pH of 4. The hydrogen ion concentration is 1 times 10 to the negative 4. OH is 1 times 10 to the negative 10. So still a small amount of OH, but compared to that negative 13, there's more OH. And there is less H. So as you move up the pH scale, hydrogen ion concentration gets smaller. That's why a pH of 5 is not as acidic as a pH of 1. There's less H. And then our bases, after you get up to 7, they have more OH than they do H. Like a pH of 9 has 1 times 10 to the negative 5 OH and 1 times 10 to the negative 9 H. So our bases have more OH, as you can see by the numbers. This is a helpful table that you might want to reference. So we have our pH scale. We also have a pOH scale, which stands for power of hydroxide. And looking at it, if something has a pH of 0, its pOH is 14. If something has a pH of 4, the pOH is 10. If something has a pH of 10, its pOH is 4. pOH of 0 means pH of 14. So what do they always add up to be? 14. So if pH is 2, what's the pOH? pH is 2, pOH is 12. They add up to 14. If your pH is 11, what's the pOH? pH 11 is a pOH of 3. So pH plus pOH equals 14. Now this gets really confusing because a pH of 0 and a pOH of 14, that is something really acidic. And then just the opposite, pOH of 0, pH 14 is very basic. And so it gets confusing with pH and pOH, figuring out is it an acid or a base. But remember, they add up to 14. Now, with all of this, we have 6 pH formulas. Write these down. You're going to want to reference them. So to figure out the pH of a solution, you'll take negative log of the amount of hydrogen ions. That just means, those brackets mean concentration of hydrogen ions. And if I wanted to get the pOH of something, I would do negative log the concentration of OH. And then pH plus pOH equals 14. And then if you wanted to figure out the concentration of hydrogen ions, you would take 10, and that's an exponent to the negative pH. So let's say I said something had a pH of 5, and I wanted to know what's the hydrogen ion concentration. You would use this formula. Hydrogen ion concentration equals 10 to the negative pH. So that equals 10 to the negative 5. And you would plug that into your calculator. And then just the opposite, concentration of hydroxide ions equals 10 to the negative pOH. And then if you multiply H and OH together, it equals 1 times 10 to the negative 14 always. And so these are our 6 formulas. Write them down, get them on a sheet of paper. You're going to need to know them. And we're going to do some example problems. So what's the pH of a solution where H plus equals 1 times 10 to the negative 9 molarity? So first you want to go look at your formulas. What formulas are we going to use? I want to find pH, and I gave you the hydrogen ion concentration. We're going to use this formula because we're looking for pH, and you have this number. We're not using this formula. A lot of people mix that up because this formula would be, you know, H plus, so 1 times 10 to the negative 9 equals 10 to the negative pH. Do you know algebraically how to solve for pH when it's an exponent? Most likely not. That's why we're not using that formula. We are going to use the pH formula because that one's just easy plug-in. So for these problems, whatever I ask you for, what's the pH, what's the pOH, that should be on by itself on the equal sign because these are weird mathematical formulas that you might not have ever dealt with before. And so to type this in, this is what your calculator should look like. Negative log, and then the hydrogen ion concentration, 1 times 10 to the negative 9. And this is from one of those websites that I put up earlier. And the log, I think, is under functions. And when you type that in, the answer is 9. So pH of 9. Now, the solution has a pH of 9. Is it acidic, basic, or neutral? pH of 9 means it's a base or a basic solution. So we're going to do another example. What's the pH of the above solution, or the problem we just did? Well, this formula, pH plus pOH equals 14. We just said the pH was 9. So 9 plus pOH equals 14. To get POH by itself, subtract 9. The POH equals 5. And again, that further proves it's a basic solution because the POH is low, which is the case for bases. Number 3, what's the pH and the POH of a solution with an OH of 1 times 10 to the negative 8? And then is it acidic, basic, or neutral? So this time I gave you OH equals 1 times 10 to the negative 8. Looking at your formulas, that's going to go into this formula. Now, what happens with a lot of people is they see this number, they plug it in, and then they just assume that's the pH. You have to be extremely careful. This is OH right here. So that means it's going to give us the POH, not the pH. It's a lot of OHs and H's. I know it's confusing. And so we're using this formula, POH equals negative log OH. We're not going to use this formula right now because we have OH. We're looking for POH. And so I plug this into my calculator. It should be plugged in just like that. Negative log, and log again is under function, and then you type that number in, 1 times 10 to the negative 8. And when you do, you get an answer of 8. And again, that's the POH is 8. And it really helps if you do these on paper and you make sure you label what is what, because it's very easy to get it confused. So if my POH is 8, remember pH plus POH equals 14. That means my pH is 6. And then a pH of 6, you hopefully can think that faster than POH. So pH of 6, is that acidic, basic, or neutral? That would be acidic because it's less than 7. And so if I ask you questions like, is this solution acidic, basic, or neutral? And I give you the POH, I like to think in pH. And it's really easy. Just change it to pH. If it's less than 7, it's an acid. And here's another one. What's the pH and the POH of a solution with H plus equals 1 times 10 to the negative 11? And then is this acidic, basic, or neutral? We're going to use this formula because we have H plus to find the pH. And put that in your calculator. You would type in negative log 1 times 10 to the negative 11, and it gives us a pH of 11. And so the POH would be 3 because they add up to equal 14. And then is this acidic, basic, or neutral? pH of 11. That is a base. And so to summarize, acids is a solution that has a high concentration of hydrogen ions, low concentration of OH, pH less than 7, POH greater than 7. Bases, solutions that have a high concentration of OH, low concentration of H, pH greater than 7, POH less than 7. And then our formulas are here. And most of the time you'll be doing these two formulas.